Okay, so can everybody see my full screen?
Yeah.
Okay, perfect. Well, I guess we can get started, and as people come in, we'll bring them in. So first of all, welcome to the UNConference. Thank you very much for taking the time to attend the event this year. We're really excited to be able to share interesting ideas with all of you, and certainly you've already seen some really great presentations given by our colleagues. So feel free to, as much as you'll be hearing from us this time, I think it's also very important for you to know that we're also very interested in hearing more about you. So if you have any feedback, comments that you would like to share with the organizers, please don't hesitate. Let us know like what interests you, what you would like to see more in the future, etc. So these are all very exciting things for us to know about. So please don't hesitate. And with that, I'm gonna start the presentation. So welcome to the session titled Capturing Reality Using Photogrammetry and in Education. So given the time that we have today, this is not going to be a very deep dive into the subject matter, but what we're really trying to do today is to give everybody a general understanding of what this technology is and how it can be relevant to us in an educational context for the Concordia community. So this is not going to be, like I said, we're not going to go really deep into the technical stuff, but we hope that by the end of it, you'll have a general idea of, what it is, what it can do, and if it's something that you would like to try, what are the specific steps that you could follow to give this a shot, to see if this is something that interests you. So here we go. Before we start, I just wanted to take a very brief moment to introduce myself so that you know who I am and where I come from. So my name is Ping, and I'm a learning experience designer from eConcordia. We were founded in 2001 and we're fully owned by Concordia University. And essentially we develop and host the accredited online courses of Concordia. So, as the professors teach in class and that they would like to transition their content online, it takes a certain level of effort to adapt and modify the content so that it becomes online friendly. So this is basically our bread and butter. This is what we do, which is why our teams, have instructional designers, project managers, and videographers, and many kind of specialists to ensure that we can cover all the bases of the faculty member. So this is just to let you know who I am. So this is the little role plan that I'm proposing for us today. So the first item is really going to the basics, right? So we're trying to understand what exactly is photogrammetry by tackling the terminology as well as the technique of how it works. The second point is doing a little case study on the Wings Noodle Factory. It's going to make more sense when I get there, so please bear with me. But the idea here would be to explain, to really explore how photogrammetry can be a very powerful tool for people in our field, in education, in academia, etc. And finally, the next step is what I call the photogrammetrician's kit. I don't think that word exists. I just made it up for fun. But here the idea is really just to go over a very short grocery list, if you will, of what would you would need to, if this is something that you want to do. So just some recommendations, some general tips. And if I manage to blitz through all of this without busting my time, then I'll be very happy to take some questions. But I'll also want to message on the platform. But if you can't find it, just feel free to drop by eConcordia.com, get in touch with us, and we'll be more than happy to talk to you more about this. So without further ado, let's get into the nuts and bolts of the presentation. So what exactly is photogrammetry? I did not really get very creative here. I just went on the internet and found some definitions from authoritative sources. So Autodesk, the 3D software developer, defines it as the art and science of extracting 3D information from photographs. And the Merriam-Webster describes it as the science of making reliable measurements by the use of photographs. So just to keep it general, it has something to do with pictures and extracting information from it. So if you want to think about it in very basic terms, that's basically what it is. But what specifically is it? So you might have seen this kind of image before. It's very popular in video game development, but also in cinema sometimes. So you can see that there are two actors, models, that are surrounded by a lot of cameras. So you have cameras pointing from every single direction, from every single angle, conceivable. So the idea here is really to create photorealistic 3D copies of real world objects virtually. So the idea is that if you have enough 2D pictures, 2D data, there are softwares that can actually reconstruct 3D geometry based on based on these 2D images. So one thing to understand is that the quality of this end result is very dependent on the number of pictures that you have, as well as the quality of these pictures. So the higher quality the images, the more images you have, the more data the software can work with, and it will give you a better, end result. So I'm going to develop this a little bit more in detail very shortly, but this is just the general idea. And one thing to know is that it's not necessarily, the pictures don't have to be all taken simultaneously. So this is another example of, you can see here, there's a bust being scanned, and every little point that you can see, the little triangles, are basically a picture. So if you don't have 200 cameras to use simultaneously, you can just use one camera and take 200 pictures. It's perfectly legitimate to do that. So this is just to give you the option that you actually don't need 500 cameras to do this kind of work. So if we want to break it down into a more like conceptual, abstract way of looking at it, so this is what the flow is, roughly like that. So you have an object in real life that you would like to photogrammetry. So you go around it, you take a lot of pictures, and you from as many angles as you can, and with the highest quality of pictures that you can get. So what you end up having is a large stack of pictures, like a lot of it. Thankfully, a lot of the heavy lifting is actually done by software. So you can dump, and I'm going to go into these specific examples a little bit later, but you dump all these pictures into the software and you make the software do the heavy lifting. I'm not going to explain exactly how the software does it because it's very technical, but basically the idea is that these software would use like AI algorithms to basically interpret the data, to analyze all the 2D information that you have, and basically attempt to reassemble this model in a 3D format. So what you end up having is basically a virtual replica of the object that you were scanning. So next, I just wanted to show some examples that we've done at eConcordia. So the example on the left side is basically a meeting room. So the idea here is just you take a lot of pictures of the room and you end up with, this is what you end up with. You can see that it's 3D and it has photorealistic qualities. And the example on the right side shows it's basically the same concept, but it features actual people. So this is just to show you that photogrammetry is basically content neutral. It's not specifically adapted to very specific topics. It can really be used in many different contexts and format. So just for fun, this is another example that it's interesting in the sense that you can also actually do photogrammetry from videos. Because I mean, in a sense, videos are basically moving images, right? It's like a lot of images. So you can actually extract a very similar amount of data from video. So you can see on here on the left side is actually the original video where it was taken. And then the right side is the end result of what it ended up looking like. Of course, when you do it like this, maybe the quality will be a little bit different, but in terms of exercise, it's a very relevant exercise anyways. And we just picked a really random squid looking alien here because, again, to show you that the content is not very relevant in the sense that you can do basically anything you want, right? So so now that we have figured out basically, like what this technology is, what it does, in very general terms, I just wanted to move over to the case study part of the talk, which can contextualize a little bit better why this technology is interesting to us, as Concordia. So I'm going to talk a little bit about the Wings Noodle Factory located in Montreal's Chinatown. So the idea here is that the story really started when many activist groups in Chinatown were sounding the alarm about real estate developers buying up a lot of land in Chinatown. And there were a lot of concerns about, development, urban development, changing the landscape and removing, historical landmarks, etc. So this is really the context of what this is all about. The particular thing, the story basically focuses on one particular building that I wanted to talk a little bit more about today, which is the Wings Factory building located on the street corner of Côté and the La Gauchetière streets. So you might actually wonder, okay, but why is this noodle factory, what's so special about this? It's like an old building, etc. So the idea is that the Gazette actually did a really cool piece on this. So if you're interested in digging deeper on this topic, please feel free to Google the Gazette Wings Factory. You'll probably find it. So it turns out that this was not always a noodles factory. It used to be called the British Canadian School. And it was actually built in 1826 as Montreal's first purpose-built school. And it was founded as a secular bilingual school for children of working class families. So the building is actually basically 200 years old with a fairly quite fascinating back history. And on top of that, as if that wasn't enough, it was also designed by James O'Donnell, who is the architect of the Notre Dame Basilica. And he basically donated his time as a philanthropic endeavor to basically help design this building. So as you can see, this building has a very long history, and it's quite connected to the greater Montreal history. And of course, when the school closed in the 1800s, it was eventually occupied by the oldest company in Chinatown, Wings. It's a pretty well-known brand amongst the Asian communities. You might have seen some of their fortune cookies around, but it turns out that they're the oldest company in Chinatown, founded in 1897. So another 100 years of history there. So as you can see, this building actually has a very, very deep and complex history that's tied with Montreal. So this basically adds a very different, perspective to the situation. And this is where the pedagogical considerations come in, right? So the idea here is, how can we conserve this piece of Montreal history, right? And how can we leverage new technologies to help achieve this goal? Because, there are many ways of documenting this kind of information, and there are many, and all of them are very legitimate. You can take photographs, you can film it, you can do sketches, you can draw things, there are many, many ways. So this is not the idea of like, what is the best way? It's just defining what are the different ways that we can use. So, and some of the objectives that we have is that we would like the information to be immersive, realistic, has a very versatile output. And I'm going to go over this a little bit in detail later, and also that it shouldn't be too cost or time prohibitive. So of course we can find, 3D artists to model this building from scratch, bring in texture artists to, texture the building, etc., and recreate it. But it's probably going to take a lot of time and it's going to cost a lot of money. So this is where photogrammetry brings something interesting to the table. So this is exactly what we ended up doing. So last year, our team actually went on site and basically did a photogrammetry exercise of this building. So you can see here just all the pictures that we've taken. I think the final tally was roughly around 800 photos. So basically we went around the building, we took pictures, etc. So what you're going to see next is the end result of this exercise. So this is actually the end result of the picture of all the pictures that we've taken. So it's a 3D model of the Wings building that you can see here with a reasonable level of detail, with a reasonable level of realism, right? So it maintained the photorealistic qualities of the building. And one interesting thing that you can see is that on the bottom of the screen, you might see a little cursor. So the idea here is that we actually placed this model, embedded this model into a web page so that anybody can just access the web page and basically observe it, look around, inspect it, zoom in, zoom out, etc. So this is what I meant by when I mentioned the versatility. So it's great to be able to extract this information, but we also have to consider how we can share this information with students, faculty, etc. But one interesting aspect of putting this on the web, and given the photorealistic qualities of it, is that it also opens up augmented reality options. So if you don't have to do it now, but if you're ever curious, feel free to scan the QR code on the screen right now with your phone. It's going to lead you to our website where you can actually, check out the model. But if your phone is AR capable, augmented reality capable, it will also have the option of launching this in augmented reality. So what this means is that you can essentially drop this model wherever it is that you're in your room as almost like a diorama kind of object. So this opens up a lot of opportunity for us in terms of curriculum design, in terms of pedagogy, etc. It's a very interesting way of delivering content to students, faculty, etc., to the rest of the community. So then the question is, okay, we can have it on the web, we can have it on augmented reality. What other options do we have? And of course, it's also usable in virtual reality, because once you have the content, once you have the model, it's essentially versatile enough for you to deploy in however many ways that you want. So this is a quick little proof of concept that our team built, where you can actually stand next to the building in virtual reality. And the very interesting part about this is that photogrammetry not only preserves the photorealistic qualities of the image, it also preserves scale. So this is actually true scale. If you're standing next to it in virtual reality, it's as if you were there in the building, next to the building. So these are very interesting ways to explore how to bring this content to to our audiences. And so, like I mentioned before, you can do it on the web, you can do it in augmented reality, what we call like content in your palm, but you can also go into virtual reality where it's as if you were there. So in the unfortunate event that the building no longer exists for whatever reason, there is this virtual version of the building that's immortal, eternal, that we can be reused and used in different ways. So this is kind of like the general idea of example of how photogrammetry can be an interesting undertaking for us. Now the part is, okay, this is really cool. Okay, this is, or maybe you don't think it's cool, but this is fun, very interesting, whatever. So is this something that you can do, or is it gonna break your bank? Like how does this work? So this is the section where we go through a quick grocery list of the items. So the idea is the first element you need is really a camera, and the idea here is that any camera taking device will work. So you don't necessarily need a DSLR camera of a few $1,000 to take pictures. You can just use your smartphone. The camera on your phone will do just fine. But of course, the thing to consider is that the higher quality your images are, well, the better the end result is going to be. But if this is something that you just want to try, you just want to see if it's interesting for you, you can just start with your phone. There's really no problem with that. It's just something that is fairly practical. A few quick tips of how to do it is that the one important thing is to consider is the consistent static lighting. So if you're photographing something, you have to make sure that the lighting doesn't shift from images from picture to picture, because that can mess up your model. So the idea here is that if you're doing it indoors in your studio, perfectly great, you can control the lighting. If you're doing it outdoors like we did with the building, we recommend that you do it on a cloudy day, because you don't want like the sun creating harsh shadows. You also don't want a cloud moving through the sun in the middle of your shoot and messing up all your lighting. So this is something that to consider. Also, when you're taking pictures, it's really good to have a lot of overlap in between the pictures. So what you don't want is to take a picture on one side and then go very far and take another picture, because the software needs these overlapping points of references to build the geometry. So keeping the pictures overlapping is great. And the final point is a little bit complex to explain, but probably won't have time to go into it. But the idea is that you're really going around the object to take pictures, and you're not doing panoramas around it. So you're not sweeping the building with your camera. You're really going around the building taking pictures. So this is basically quick tips on the photo taking aspect of it. So the secret sauce of photogrammetry is really the software that does a lot of the heavy lifting. So I just put two examples here. Reality capture is basically the industry standard. It's a very powerful tool that a lot of people use. The only downside is that it's a paid software. But the interesting part of this is that there is a trial mode where all the features available, you just can't export anything. So if you're just trying to mess around, play, and experiment, this is an option. I actually tried Meshroom, which is a free software. It does the work as well. So if you want to try, whatever it is that you feel like trying, just feel free to give it a shot. There are a lot of software out there, so you can just Google like top photogrammetry software, and you'll get a lot of paid and free options. So I can only talk about Meshroom because that's the one I tried, but there are really a lot of options out there. In terms of 3D editing, sometimes you might have to clean up the models for whatever reason, or sometimes you want to modify the model. So this is really depends on your comfort level of manipulating 3D content or 3D models. So here, Blender does the job. I use it very often. So you can see on the left side, the example here, we tried to add in the missing pieces of the model, so this is kind of something that you can do. Or if you're already familiar with the industry, with the technology, Maya, 3ds Max, all these industry standard software will just do fine. The interesting part of this whole thing is, okay, now that I have the content, is it super difficult for me to deliver it to the students or to deliver it to my peers, my colleagues, etc.? So if you're really familiar or comfortable with like web design and things like this, you can use different frameworks to integrate this content on the web page, etc. This is basically what we did. We used Google's model viewer framework to basically combine the 3D model and the augmented reality component. But if this is something that you just want to try for fun, whatever, Sketchfab is a really great platform. You just create an account there, you upload your models. It can be as simple as sending a URL to someone, and and they get it, they can use it, they can view it, etc. So you can just, for example, check the QR code. It just boom, directly sends you where you're supposed to go, and you can basically already start sharing the content. So then the interesting question, of course, is that, okay, well, this is very digital, virtual, and all this stuff. Is there other ways of doing it? And of course, actually, our colleague Yasha from the Concordia Library earlier did a really great talk on 3D printing. So is this in any way compatible with 3D printing? Well, short answer is yes, in the sense that you basically end up having a 3D mesh, a 3D version of whatever it is that you were trying to capture. So the idea here is that these models can be 3D printed to some extent with some work, with some cleanup, but this is a little bit beyond the scope of the talk. So please feel free to refer to Yasha's talk earlier, or swing by the technology sandbox of the library. If this is something that interests you, you want to dig deeper, look into it, this is a really, the two actually synergize each other extremely well. So this is something definitely to consider. I'm going to quickly try to wrap up because I went slightly over time. So this is the conclusion that I have today. 3 points. The first idea is that we really advocate in Concordia that people drive the technology. So photogrammetry is a solution, but it's not the only solution. And we also always have to consider the pedagogy, the instructor, the students, etc. So a lot of times technology gets bad reputation because people try to put it everywhere. They jam it in and in places even when it doesn't work. And this gives people the wrong impression. They get turned off, they don't like it, etc. So this is something that's very important to keep in mind, that you're always doing it because you have a reason to do it, and you're not doing it just for fun. Like, I mean, you can do it for fun, but I mean, if you're deploying it in the curriculum, it has to have a pedagogical rigor and purpose to it. The next one is, if you can physically scan it, you can probably capture it. So the idea here is, whether it's something as simple as on your desk, something in your room, like a piece of furniture, or even a building on the street, if you can physically photograph it, there's a pretty good chance that you can capture at least parts of it, right? So a high, but to keep in mind that the more images you have, the higher quality your images are, the better your end result is going to be. But also to consider that it might also take you more time. So just like 3D printing, when it takes a while to get the model out, the computer will also work really hard if you have a lot of data to interpret, assuming that you don't have a monster machine that can power these things. And the final thing is, really anyone can try it, right? So as I mentioned before, you don't necessarily need crazy equipment. You can just use your phone, take pictures of it, dump it all into a free software, try it. Immediately you get an idea of if this is something interesting for you, and etc. So this basically wraps up. I just want to do a very tiny little epilogue. I did not expect this to happen, but it did. So I just figured I'll mention it as a epilogue to my little story on the noodles factory. It turns out that just as earlier this week, Chinatown is going to receive Quebec heritage status. And very interestingly enough, specifically, they identified 2 buildings. So the former S. Davis and Sons factory, and of course the Wings factory. So this is actually very interesting. Maybe the threat of demolition now is temporarily postponed, but I think it was still a very interesting exercise of examining how this technology can be interesting for us at Concordia. So yeah, this basically wraps up my talk. I'm really sorry I went a little bit over. So if you have to run, please don't feel bad. I can stick around a little bit if you have any questions. Let me check the chat. Like I said earlier as well, if you don't have any questions today, that's perfectly fine. Feel free to reach out to us, later. You have my contact information. It will be really great to, continue talking about this. So. All right, thank you, thank you. All right, I guess there are no questions. All right, so I hope you guys have an amazing rest of the day, and you keep finding other interesting talks that other of our colleagues are presenting, whether it's Moodle, accessibility, all these things. Please feel free to drop by and check things out. All right, thank you very much, everybody.